Okay, in the one that we looked at before, we assumed that our asymptote for that exponential equation was 0. What if it's not 0? So we're going to look at another problem where the asymptote does not necessarily have to be 0, okay? We can use the same type of approach here and, plug in values, but we're going to try to figure out what our asymptote is based on what we know about the equation. So first of all, we have assumed the graph of an exponential function passes through the 2 points that we see here, which are 312.5 and 411.25. Is this exponential function increasing or decreasing? In other words, as our x's get larger, is our output getting smaller or larger? In this case, as we go from x equals 3 to x equals 4, we see our y value goes from 12.5 to 11.5. So this is decreasing. Okay, if the horizontal asymptote for this function is the line y equals 10, let's make a sketch of the graph. Okay, so sorry about that. Let's go ahead and sketch what we know. So we know we're told that we have a horizontal asymptote at y equals 10. So I'm going to draw in that horizontal asymptote at y equals 10. And then I just want to plot the 2 points that I'm given. So 3, 12.5. This is counting by 2's on your y-axis, and watch your scale on your x-axis. So 3, 12.5 would be like right here. And then 4, I can't see it, 11.25. So at 4, we are at 11.25. So we're just about right there. So we have a couple of points. Now, if you wanted to sketch in, really roughly sketch in what that graph might look like, you'd see it's an exponential function. How it's increasing, though, becomes a little bit harder to figure out. Maybe it looks like that. We don't know. We're going to get some more information to try to actually figure this out better. So let's talk about the equation now. So the equation, since we have an asymptote that's not 0, we have to include that in our kind of generic equation. This time we know that the value of c, though, is 10. All right, so we have 2 equations that we could write. Let me write out what our generic equation looks like. We've got 2 functions, or 2 points we can use. We can plug in 3 and 12.5 and 4 and 11.25. And just like before, I'm going to do the 4, 11.25 first. So I have 11.25 equals AB to the 4th power plus 10. And then I have 12.5 equals AB to the 5th power plus 10. Now, before I do anything, I want to go ahead and subtract 10 from both sides of that equation, of each equation. So I'm going to do that here, and that's going to give me 1.25 equals AB to the 4th power. And the reason I'm doing this is that it will allow me to then go ahead and divide the 2 equations by each other. And then I'll have 2.5 when I subtract 10 from both sides equals AB to the 5th power. I'm sorry, that's 3rd power. Let me fix that. So that would be AB to the 3rd power. Sorry about that. All right, now we've got our 2 equations here. I want to go ahead and solve that system. And just like I did in the previous problem, I'm going to go ahead and divide the 2 equations. Now, you could also solve for A and then find B using A. But what if I divide the 2 equations? So if I divide 1.25 by 2.5, I get 0.5. All right, and then A divided by A, that's a giant 1. And then B to the 4th divided by B to the 3rd is just B. And look at that, we found B. So now we have B. We can use that to find A. Well, I'm going to plug that back into one of my original equations. So I'll use, it doesn't really matter, let's use the one with the smaller B value. So 12.5 equals A times 0.5 to the 3rd power plus 10. And we're going to solve that for A. So subtract 10 again from both sides. a times 0.5 to the third power. And then you'll have to do 0.5 to the third power. Guys, you can always do this using fractions, right? I mean, we could do 1/2 to the third power, and you'll still be able to get the right value. But if we do 0.5 to the third power, we get 0.125. So we have 0.125 times a, and then let's divide 2.5 by 0.125, and we get 20 equals a. So we could write our equation. Okay, so our equation is just going to be given by y equals a, which is 20, times our b value, which is 0.5 or 1/2. So I could write this either way. I personally like the 1/2 a little bit better, but I would take either one. All right. So let's find the y-intercept of this function. So the y-intercept is where our graph will cross the y-axis, right? So we're going to plug in 0 for x. So if I plug in 0 for x, I will get y equals, I forgot the plus 10 on these. Let's not forget that. That's really important. Y equals 20 times 1/2 to the 0 power plus 10. And then it's just a matter of simplifying. So I know that 1/2 to the 0 power, anything to the 0 power is just 1. So what I really have here is 20 plus 10, so y equals 30. So my y-intercept is 30. So that's actually where my y-intercept is. Now we were kind of close in our estimation, but let's go ahead and make this graph a little bit better. So I'm going to actually draw in a better sketch for my graph, connecting the points that I know for sure. So I have something that looks like this. Now, as far as the connection between the y-intercept and the asymptote, I mean, it's your start value plus 10. You can think of it that way if you'd like. There's no real other connection that I'm looking for there.